Hello everyone, thank you for watching Robo Learning channel. My name is Mohammed. In this channel I am presenting some tutorial about robotics. You are watching section 4 of series of ROS for beginners. Into three previous sections we did talk about the basic for robot operating system, and in the previous video I presented how to make a four wheel robot model in Gazebo, how to create a URDF and some basics for RVs. In this section I want to talk about uh, how how to add the plugins in a Gazebo model. So in this video we will learn how to add a depth camera as an example and a laser camera, and visualizing in RVs. So uh, I open a terminal. Let's open a new one. Okay, this is the URDF that we discussed in previous section. You can watch the section 3 in my YouTube channel. I will add the link in the description. Okay, first of all we have to source to over ROS Catkin workspace YT for Miss Devil setup bash. Okay, I will launch the ROS launch file for Gazebo that I created before. Press 2 tab, which is Gazebo. So this is the Gazebo model that we created in the previous section. There is a four wheels that connected to the one body frame through the continuous join. Okay, in this section I will going to add one camera here and a laser on the top of the body frame, which is the red frame. Okay, yeah, I will kill this Gazebo. Okay, for the plugins, this is our reference. You can see the different plugins such as camera, depth camera, and this is the Kinect, which is the depth camera, Microsoft Kinect. This is GPU laser. We are going to use this too. So this is the Gazebo plugin. Okay, we are supposed to add this to our URDF. Okay, and this one, the Hoko is a type of laser sensor. Okay, if we add these plugins and create links for them, it will be supposed to be okay, right? So this is our URDF previously we created. So first of all I should add a camera frame that I provided before to save the time. If I can find it, this one. Okay, this is the camera frame. Okay, this camera frame is a sphere that connected to the base link through the fixed joint. So we just copy and we will add to our model. Let's see. So this is the link defined for the camera frame, which is added in front of attached to the body frame, and this is connected to the base link as a parent. Okay, so how to make a link already we discussed in the previous section. You can watch, you can refer to our previous section. So we'll check the model in Gazebo. Is everything okay or not? So you can see this color white one. Okay, we can add a color, for example blue. Blue would be nice. We should go here. Okay, we just add to over, we change it as a link 4, we change it as a link camera, and refer to what's the name of the link, camera link. Okay, just copy and we'll add the name, link name here, and this is the explanation description. Okay, but we want something like blue. Okay, let's see. Okay, you can see it's converted to blue, but it's a empty link. So we want to add a plugin, camera plugin to this big camera link. Okay, so we refer to this depth camera in this website, the Gazebo website, wiki website. Okay, so I already created this one. I add at the end of my URDF. So you can see that it's a reference to the camera link, and this is the plugin. Okay, this is the source file. Is is a library. Sorry, is a library for the Kinect, and this is the size of the image, and you can see the topic names here. So we save and we try again. Okay, we open another terminal, we check ROS topic list. You can see the camera topics are added already. So let's look at the camera image. We use RQT image view, so you can see, visualize here the image raw. So for instance, I'll add the box in my Gazebo world, and you can see this one is here, right? So if I move the robot, ROS run turtle bot 3. Okay, So if I move it by my keyboard, you can see the robot is moving. You can control it through your camera view. Okay. uh, Stop it, no need. I'll add, ah, we should supposed to visualize it in rviz. Let's see how to visualize the model in rviz. I killed rqt because it's slowed down my pc. Okay, in here we go we select add on the left, we go by topic and the depth glow. Okay, and I would like to add the image. Okay, we have image but we don't have the depth one. Okay, let's see why we cannot represent the depths. There's supposed to be a problem in here. Kill all. Let's go to okay, I think this update increase to 100. What will happen? We can visualize the depths camera or not. Run Gazebo one more time, then open rviz. Again select topic, depth camera, we select the base footprint, then we go, can visualize or not. Sorry. Add the image. We add one box here. Okay. So I still cannot, let's say kill all the Gazebo and rviz. Okay. Already changed to 100. Let's run one more time again. Okay, run rviz one more time. Go to the add and still okay. But here on only can see 2 fixed frame. I cannot see the other frames. I think because in the Gazebo launch file I forgot to add the robot joint asset publisher and robot publisher. So I will add in the one node. One is name equal to robot state publisher. Okay, I just copy this. Then we need one package. Add quota, paste, and after that is the type, right? Supposed to be type, yes, type equal to quota and robot set publisher. So repeat one copy here and paste. Change the robot to join the set publisher. Join the set publisher. These two nodes connect the robot asset publisher, connect the fixed frames to each other, and joint asset publisher connect the continuous joint type joints to the body frame. Let's run the Gazebo one more time. And in the RVs here you can visualize, see all the joints are appear here. So if I go to the robot model, then I select paste link, you can visualize all the model in RVs. So I go to depth camera, see you can visualize here. So the problem was we forgot to add this node, robot state publisher and joint state publisher. Okay, we have the depth camera view. Add one box in the wall, Gazebo wall, and we can visualize in here. See, you can visualize in here. Okay, this is the camera frame. We can depth camera frame. We can have the camera, and we can go to here, select image topic, then go to image. We can select not depth. We can select row. That you can visualize. Then if I run the Tello, then you can visualize the movement in Gazebo and RVs. Okay, let's kill our Gazebo, kill the RVs, kill this one. Okay, for the next plugin, same scenario, we're supposed to add one frame for the laser, okay, and the plugin. So I already created the Pocoyo link. This is the plugin, this is the this is the link. First we will add the link. Okay, it's calling the mesh file. We can see that this mesh in this link, the difference is here we define, for example, different shapes. For example, here cylinder, here is fire, the other is boxes. We also can have we can add mesh in URDF. So where the mesh is, it is the folder inside which is saved in the meshes folder. You can, for example, you can create one STL file of your model in any CAD software, in SolidWorks, in CATIA, in FreeCAD, anything. Then you can save it as a STL file, save it in your folder, and in your URDF file you can call the STL file. So in the laser link we use the mesh file for the Hokuyo. Okay, link is added. What we need is the join to connect it to the base, so which is better to copy from here to save the time already. I created already. Okay, you can see the Hokuyo link connected to the base link parents, and this is the, we don't need access because it's a fixed frame. Okay, we save, run one more time, we can visualize it or not. Everything is okay. This is the Hokuyo mesh file. Okay, we can see it's better quality and more complicated shape. For more complicated shape you can create the cat file. You can create STL file or D, what's the name, D AE file format, and save it in your folder and call it in your URDF file. Okay, for the plugin I use this plugin. Okay, which is the same that I have in here, so I just copy and save in my URDF file at the end of it. So you can see the angle minus 90 degree to 90 degree, and inside the resolution is 720. Will be every 0.5 degree you can have one pulse. So the topic name we can make it as a scan only. No need to make it complicated, and save it. So this laser scan can be used, for example, for mapping, navigation. Later we will see, and you can in the for the navigation we can use this laser scan. And this is a framework which is a Hokuyo link we define already. Reference, which is the the name of the link, Hokuyo link, and this is the library for the laser. Okay, let's kill our previous Gazebo and restart it. So I open another terminal, ROS topic list, to see the topic is here. Topic is here. ROS topic echo to read the data. There's no problem. Okay, you can see the data. If I add one box in here, you can see the differences. Okay, because the resolution is so high. Okay, let's kill this one, delete this one first, then I open rviz. Here I select the footprint. I will add the robot model. Problem. Okay. Here we see the error. That was a problem. Cannot read the Hokuyo DE. Cannot find. Okay. We kill rviz one more time. We run it. The problem is we forgot to source the our Catkin workspace. We will set up bash run the rviz one more time. You can select the footprint and problem solved. So there's no error. So we can add our robot model. You can visualize it. Okay, we can add depth camera here. We can add, go to here, laser. Okay, then the topic is here. The problem is we don't have any obstacle in our model, in our world. So you can see the laser frame, laser beams, right? So you can see it's already added in our the boxes added in our model. You can visualize it in our depth camera and our laser. If I move my model, the mobile robot model, through this turtle sim, can visualize it that it's moving in Gazebo. You cannot see it. Okay, my monitor is quite small. Okay, you can see when the robot is rotating, we can visualize our laser beams and the depth camera. Okay, let's kill it. Okay, let's conclude our section, our tutorial, that we learn how to add the plugins inside Gazebo and visualize in rviz. We use two different plugins, the depth camera and the laser. You can add other plugins, same as such as IMU. You can add, for instance, the 3D laser like Vlodyne, the model. This one we use Hokoyo, right? The other model for the famous laser, 3D laser called Vlodyne. You can add this plugin. You can have the 3D mapping with that. So in we add this laser plugin. Later we can use it for SLAM and for navigation of the our Gazebo model inside the Gazebo world. Our mobile robot, we create a new world in our Gazebo, and we will navigate autonomously through the lasers. Okay, thank you for watching this video. Please subscribe my channel and like the video. Any question, please ask in the comment section. Thank you for watching, and please subscribe my videos. Thank you.